Okay, now we'll work out some examples of finding an indefinite integral. So in the first case, we are finding the indefinite integral of 2 dx. Right? So let's go ahead and rewrite that with a variable in there. So if it's just 2, that means that x is raised to the 0 power. Okay? And that's dx. Okay? Now then, by the rule that we can go ahead, we can take a coefficient and move it out in front of the indefinite integral. So I can take this constant coefficient of 2, move it out in front, and then this becomes the indefinite integral of x to the 0 dx. And now I can go ahead, I can apply the rule for doing the power rule for indefinite integrals. So what I do is I take x, and then I take the exponent plus 1 and put that over the exponent plus 1. And then I can't forget my plus c because it's an indefinite integral. So when I do this, well, 0 plus 1 is just 1. So this becomes 2x plus c. And I can very quickly see that if I take the derivative of 2x plus c, the derivative is 2. Okay, next one, 16x dx. Again, I can take my constant coefficient there of 16. I'm going to move that out in front and then take the integral of x. And here x is raised to the first power dx. So when I do that, I know that becomes 16 times x to the 1 plus 1, because I take my exponent and increase it by 1, and I put that over 1 plus 1. Okay, well, 1 plus 1 is 2. This is the same thing as 2. Okay, and then I can't forget my plus c here. Well, okay, when I do that multiplication out, I can cancel out the 2 with the 16. Okay, and this answer becomes 8x squared plus c. And again, I can very easily see that when I take the derivative of 8x squared plus c, 8 times 2 is 16. That's going to be multiplied by x. And the derivative of c, since it's a constant, is going to be 0. All right, next one we have is the integral of x to the negative 4th dx. All right, I don't have a coefficient out in front, so I don't need to worry about moving that out. So I can go right to my power rule. So I go x to the negative 4 plus 1, because I add 1, over negative 4 plus 1. So when I do that, and then don't forget the plus c. Okay, so this becomes x to the negative 3rd over negative 3 plus c. Or you can write this as negative 1/3 x cubed plus c. All right, now we'll do one more example. So here we have the integral of 2x to the 5th minus 3x squared plus 1 dx. Now then, remember that the last rule that we had, or the last property that we had about indefinite integrals, was that when we have functions that are added or subtracted to each other, we can break them up and deal with them individually. So I can, here, instead of looking at 2x to the 5th and minus 3x squared plus 1 as a single entity, I can look at this as the integral of 2x to the 5th dx plus, or actually I can even just say minus 3x squared dx, okay, and then plus the integral of 1 dx, just like that. Okay, so what this becomes is, so 2 times the integral of x to the 5th dx minus 3 times the integral of x squared dx, okay, plus, and when I factor out the 1, remember I'm taking the integral of x to the 0 dx. Okay. So now I can go ahead, I can do each of these individually. And the great thing is that I only have to add one constant, one c at the end, okay? Because c just represents an arbitrary constant. So whether you have 3 of them or 1 of them, it doesn't matter. It just represents a number. Okay. So I have 2 times x to the 5 plus 1 over 5 plus 1 minus 3 times x to the 2 plus 1 over 2 plus 1 plus x to the 0 plus 1 over 0 plus 1 plus c. Okay, so 5 plus 1, that's just 6. Okay, and I can go ahead, I can cancel the 2 with the 6. That leaves me a 3 in the denominator. In my next one, 2 plus 1 is 3. So the 2 3's there can cancel each other out. Okay, and then in the third one, the 0 plus 1, that's just 1. So I have 1/3 x to the 6th minus x cubed plus x plus c, and that is my indefinite integral solution right there. And again, if I take the derivative of this, 6 times 1/3 is 2, so it would be 2x to the 5th. 3 times -1 is -3 times x squared, and the derivative of x is 1, and the derivative of c is 0.